China's Tianwen-1 released the images. The European Space Agency shared their spectroscopic findings. Amateur astronomers uploaded tracking data. But NASA? NASA stayed silent until they could no longer hide what they found. 3,000 kilometers. That's how far the plume extends. Not behind the object, not toward the sun. Forward, ahead of the nucleus, in the direction of motion. Natural comets don't do this. Ever. When NASA finally released the HiRISE image, astronomers discovered what institutional science had been avoiding. 3I Atlas isn't behaving naturally. Avi Loeb saw it immediately. This is not normal for natural comets, at all. The geometry doesn't lie. To understand why this image changes everything, we need to understand what HiRISE reveals that Hubble cannot. The Hubble Space Telescope has tracked 3I Atlas since its discovery. Hubble's resolution is extraordinary, capable of distinguishing features down to several hundred kilometers. But Hubble orbits Earth, and from that perspective, 3I Atlas presented a geometric problem that made interpretation nearly impossible. For months, Hubble observed the comet when the sun's direction and the object's motion vector were almost perfectly aligned. Imagine trying to determine whether a car's headlights point forward or sideways when you're standing directly in front of it. The alignment creates ambiguity. Is the plume pointing sunward due to radiation pressure? Is it trailing behind due to sublimation lag? The geometry made definitive answers impossible. HiRISE shattered that ambiguity. The high-resolution imaging science experiment orbits Mars, not Earth. When 3I Atlas passed within range of the red planet, HiRISE captured the object from a completely different viewing angle. The sun was off to one side. The motion vector clearly defined. The plume alignment became geometrically undeniable. From Mars' orbit, HiRISE separated variables that Earth-based observations had conflated. The plume extended perpendicular to solar direction and parallel to velocity. This wasn't ambiguous. This wasn't subject to interpretation. This was observable geometric fact. Loeb explained it directly. It appears like there is something preceding the object that was previously confused with being in the direction of the sun but is actually in the direction of motion. Michio Kaku, theoretical physicist and space science authority, has noted that orbital geometry often reveals what magnification cannot. Sometimes it's not about seeing smaller details, Kaku explained. It's about seeing from a perspective that eliminates ambiguity. The HiRISE perspective eliminated ambiguity, and what it revealed was a plume structure that natural comet physics struggles to explain. A forward-pointing extension, coherent and bright, stretching 3,000 kilometers ahead of the nucleus. Not diffuse, not random, not scattered by solar wind, directional. That directionality carries information. Information that contradicts everything we know about natural comet behavior. Let's establish baseline comet physics. When a comet approaches the sun, solar radiation heats its surface. Frozen volatiles, water ice, carbon dioxide, methane, ammonia, sublimate directly from solid to gas. This gas escapes the nucleus, carrying dust particles with it. The result is a visible coma and tail structure. Tails point away from the sun, always. Solar wind and radiation pressure push material outward, creating the iconic comet tail visible from Earth. We've observed this behavior thousands of times across centuries of astronomy. It's foundational. It's predictable. It's physics. Gas jets can point toward the sun if surface vents face that direction. Sunlight hits ice pockets directly, creating concentrated jets that glow intensely on the illuminated side. We've documented this on Comet 67P Churyumov-Gerasimenko, on Halley's Comet, on dozens of others. This is normal. This is expected. But a forward-pointing plume, 3,000 kilometers ahead of the nucleus, aligned with motion, independent of solar direction, that breaks the model. And it's not the only thing that breaks the model. 3I Atlas exhibits 12 documented anomalies. 1. The sunward jet persists far longer than natural models predict. 2. Nickel to iron ratio contradicts solar system formation chemistry. 3. Negative polarization, a phenomenon never before observed in comets. 4. Extreme carbon dioxide dominance inconsistent with expected volatile ratios. 5. An improbably aligned trajectory through the inner solar system. 6. Blue-green luminosity unexplained by standard spectroscopy. 7. Jets producing thrust 5 billion tons beyond what size predictions allow. 8. Rotational stability defying expected fragmentation physics. 9. Velocity profile suggesting non-gravitational acceleration. 10. Thermal signature inconsistent with passive ice sublimation. 11. Mass distribution incompatible with natural comet density models. 12. Forward plume geometry contradicting all comet tail physics. 12 anomalies, not 1, not 2. 12 simultaneous deviations from natural behavior. At typical sublimation velocities of 0.5 to 1 kilometer per second, material would require less than 1 day to travel 3,000 kilometers. This means the plume isn't static, it's dynamic, actively maintained, continuously replenished. Natural sublimation doesn't produce this geometry. Gas escapes based on surface heating and nuclear rotation. It disperses in multiple directions determined by vent orientation and solar angle. It doesn't organize itself into a coherent forward beam stretching thousands of kilometers. It doesn't maintain directionality independent of external forces. And then Loeb asked the question institutional science refuses to ask: could this be a technological signature of illuminating or clearing the path from any hazardous micrometeorites that may cause damage to a technological object? Not speculation. A calculated hypothesis based on geometric evidence. Path-clearing mechanisms exist in theoretical spacecraft design. Forward-facing particle deflection. Micrometeorite protection systems. Active navigation assistance. These aren't science fiction concepts. They're engineering solutions to real interstellar travel problems. Loeb isn't claiming 3I Atlas is artificial. He's asking whether the evidence allows us to exclude that possibility. There's a difference. Science advances by eliminating hypotheses that don't match data, not by clinging to comfortable explanations that ignore anomalies. Natural comets don't project material ahead of themselves for extended distances. But engineered systems designed for interstellar travel might need to. This isn't speculation. It's pattern recognition applied to anomalous data. And the data refuses simplicity. When HiRISE captured the 3I Atlas image, the data showed an anomaly institutional science couldn't easily explain. So institutional science did what it does when evidence contradicts narrative. It delayed, minimized, and obfuscated. While China's Tianwen-1 mission published Mars orbital imagery of the interstellar object, while the European Space Agency shared spectroscopic findings, while amateur astronomers uploaded tracking data to public databases, NASA remained conspicuously silent. When the HiRISE image finally emerged, it arrived without analysis, without commentary, without acknowledgement of the forward plume's significance, just raw data, a brief technical caption, and institutional silence. Giovanni from Belgium, a researcher following Loeb's work, captured the problem perfectly. Yesterday's NASA presentation left me uneasy. The absence of the long-anticipated HiRISE images, along with explanations that seemed more like public relations language than scientific clarity, reminded me how important it is to have independent voices willing to ask difficult questions. Adam from Poland wrote something even more striking. None of your critics have been able to address the 12 anomalies. Even if 3I Atlas changed course and headed straight toward Earth, some of them would still insist it was just a comet. This isn't skepticism. This is institutional denial. Avi Loeb's response remains consistent. Science does not advance when we avoid anomalies. Science advances when we confront them. The forward plume should not be dismissed, not ridiculed, not ignored. It should be treated as a scientific clue requiring investigation. But institutional astronomy has developed a pattern. Oumuamua accelerated without visible outgassing. explained away with theoretical hydrogen ice. 3I Atlas produces jets billions of tons more powerful than size allows, dismissed as fragmentation without observed fragments. Now the forward Plume, NASA's explanation, pending, or more accurately, absent. The gatekeepers of cosmic knowledge have forgotten a fundamental principle. Science is evidence, confronting ignorance, not narrative protecting certainty. The refusal to publicly ask, what if our models are incomplete? The forward Plume is not the end of investigation. It's the beginning of a binary test. In the coming weeks, large ground-based telescopes, Hubble and Webb, will measure three critical parameters: jet composition, Plume velocity, and mass loading rate. These measurements will answer a binary question Loeb has framed with scientific precision. Are the jets produced by natural ice pockets warmed by sunlight, or by technological thrusters? The evidence will distinguish between these possibilities. If natural sublimation drives the jets, spectroscopy will reveal water vapor, carbon dioxide, methane, the standard volatile suite. Velocity profiles will match thermal escape speeds. Mass loading will correspond to solar heating intensity. But if the jets originate from technological systems, the signatures change. Composition might include unexpected ionized species. Velocities might exceed thermal predictions. Mass loading might remain constant regardless of solar distance fluctuations. Loeb's framework extends further. Natural fragmentation produces ice fragments. We can search for them. Technological systems might deploy mini-probes. We can search for those too. This isn't speculation. It's testable, falsifiable science. The kind institutional astronomy should embrace, not avoid. James Webb's infrared capabilities will measure surface temperature distribution and thermal signatures. Hubble will track plume morphology evolution. Ground-based spectroscopic arrays will analyze chemical fingerprints with unprecedented resolution. Each observation constrains possibilities. Each measurement eliminates hypotheses that don't match evidence. Rubin from India, writing to Loeb, captured what's at stake. You are attempting to give the world something it has never had, a disciplined framework for investigating the unknown. That framework is being applied right now. The tests are coming, and the universe doesn't compromise on evidence. When NASA finally released the HiRISE image, institutional science could no longer avoid the question geometric evidence had been asking. What produces a 3,000-kilometer plume ahead of an interstellar object? Avi Loeb has been right before. He predicted Oumuamua's anomalous acceleration before evidence confirmed it. He predicted 3I Atlas would exhibit unusual chemistry. The nickel-to-iron ratio validated his analysis. He predicted institutional resistance to transparent investigation. NASA's delayed release proved it. Now he's identified 12 simultaneous anomalies that refuse natural explanations. Adam from Poland wrote something that captures this moment perfectly. This reminds me of Arthur C. Clarke's Rendezvous with Rama. The difference is I'm not reading about this in a book. I'm watching it unfold in reality. He's right. We are witnessing something unprecedented. 12 anomalies. Forward plume geometry defying physics. Binary tests approaching that will answer the technological question definitively. The HiRISE image doesn't show a comet misbehaving. It shows an object that challenges fundamental assumptions about what natural objects do. Future observations will determine whether our models need adjustment or replacement, whether the path ahead is cleared by sublimation or something else entirely. Whatever the answer, the evidence is coming. Stay curious. The universe is about to teach us something new.